Okay, so I finished building the state machine, and let's review all the different steps that I went through. So I opened the servo here and save the reference. You'll see that I made a little bit of mistake here. I swapped the agitator reference in the command actuator data. Yours was probably reversed if you did it correctly. But it doesn't really matter as long as you have it in the cluster and you unbundle it correctly. And then we go to our read input data. So we read our command actuator agitator data, and I had to create an enum for that. So let's see, if I open the front panel, you'll see I have an enum that's disable and enable according to our state machine, and one item, and I've named it command actuator agitator data to following our naming convention rules. And I'm also reading from my network table variable here, like they were doing in the other code, and we save it to our agitator speed, and our agitator speed is in sweeps per second. So actually, let's add that so we remember the units. Sweeps per second. Get a little bit longer, bigger, but I'm gonna control drag here and give myself a little more space. And then I'm going to clean up these wires. All right, and then the next section, we didn't add any additional calculations. We decided to do our calculations in our action cases. And then we come to our states, and we start with our startup state. Our startup state, according to our state machine, should just go directly to off, and it does with no action. Our off state looks at our command, and either we're enabled or disabled. If we're disabled, we come back to the off state, and if we're enabled, we go to the sweep right state, and we save our time and save our position. And so if we are disabled, if we are enabled, we go to our sweep right state, save our time, save our start position. Our next state is our sweep right state. Sweep right state, we look for command enable, and our position is less than 70. We stay, we do an increase our position and come back to sweep right. So if we are enable and our position is less than 170, true, we sweep right and increase position. If our command is enabled and we are greater than or equal to 170, we will go to sweep left state, save our start time, save our start position. And then finally our sweep left, we're looking for command enabled. If we are less than, if our position is less than 0 or greater than 0, we decrease our position. True, greater than 0, stay in the sweep left state, decrease position. And if we are not greater than 0, equal to 0, or less than 0, we go to the sweep right state, save our start time, and save our start position. All right, and then we do our actions. So our reset time and reset all. I decided to take all the code out of reset all because there's not really a reset. We don't want to move our servo. We just want to always leave our servo exactly where it is. We don't want to reset it to 0 or anything like that. So we're going to, for save start time, we just take our current time and write it to start time. For save our start position, we write our current agitator position and write that to start position. For increasing our position, we try and follow this formula here. So our sweep speed is equal to agitator speed times 170. So agitator speed times 170 equals our sweep speed. Our degrees to move is our sweep speed times our current time minus our start time. So here's our current time minus our start time. That should give us the time elapsed. And then we multiply that by our sweep speed to get our degrees that we need to move. And then we add our degrees to move to our start position. And that will give us the total from our start position to the degrees to move, what our new agitator position should be. And our decrease position is exactly the same, except we subtract from our start position what our degrees to move should be to get our new agitator position. And then finally we write our outputs. So we write our actuator, this should be agitator position to our front panel so we can view it, and our cycle time. And here we are bringing our agitator position and we are putting it into a range function. So the range function, what it does, Control H, is it forces it to be in range. So we don't want to set our servo angle greater than or less than 0 or greater than 170 because we could damage it. In real life, you could damage a servo if you try to give it too high of an angle. So we're going to limit it to being 170. So if by chance the agitator position when we calculate it over here goes negative or goes greater than 170, we're going to force it to 170. And we're actually going to then, we're going to come back and we're going to rewrite our agitator position to what we set it to, not to what we can, after we've calculated it, so that it always stays between 0 and 170. And that's our agitator code. So let's test it. So we're going to bring up the global variables that we need. So one thing, in order to test this, we need to be able to run this. So I'm going to just create a constant here because we aren't going to be able to have our network tables running until we get our dashboard running. So I'm going to delete this wire and I'm going to create a constant here. And I'm just going to say we're going to run it a sweeps per second, or I'm sorry, 0.5. I want 0.5 sweeps per second. So I want it to move half a sweep every second. So it should take 2 seconds to do a complete sweep one way and 2 seconds to do a complete sweep the other way. All right, and we should be able to test it. We may have to take this network table. It may generate an error because the dashboard is not running, but I'm going to disable that code. So I'm going to go up here to structures. I'm going to grab a disable structure. So if we ever want to comment code out, you just wrap it in a disable structure. You'll see it'll gray it out, and then LabVIEW will not look at that code. So we won't accidentally generate an error if that isn't working correctly. And then the final thing I forgot to do is create a header or template for my library. So let's go Control-Shift-E. Let's go to our, library. We're going to right-click in here and go back to Properties, and we're going to build an icon, a unique icon just for our agitator. So we're going to edit the icon. and I am going to select the color green and dark green border, light green background, and type Agitator. All capitals, A-G-I-T-R. Just shorten it so it fits in there, Agitator. And I'm going to make that my header for all my VIs in this library. Click OK, click yes, and then see now all my VIs that are in that library change their headers to Agitator. Okay, so we're ready to put our Agitator loop into our main VI. So let's go find our main VI. I'm going to go Control-Shift-E and go to our project. And then I'm going to go here to Time Tasks, Periodic Tasks. And then I'm going to select the VI and put in my actuator loop. Demo, RoboRio, Systems, Agitator, Agitator loop. I'm going to call this actuator loop. All right, and then I need to get rid of all the actuator loop code, so we can get rid of this, all of this. And you need to go to begin and remove that code if there's any there. I think I may have already removed it. I did. And we need to go to finish. And see if there's any actual code there. Okay, so we've gotten rid of all the Agitator code that was previously there and replaced it with our own. All right, so now let's go to teleop and see how do we want to control this. Main, going to open teleop, and then we need to bring in our command for our agitator. So we're going to bring in our command cluster for our agitator. So I'm going to go select VI. I'm going to go to System Agitator, and I'm going to be the command, the cluster, the command actuator data. Bring that in. I'll double click on it, and then I'm going to do an unbundle by name. And there's my agitator command, and now I need the global command, the variable, the command actuator agitator data, the global. So I'm going to go select that. Here's my global command actuator data. All right, and so I have the option to disable or enable my agitator. All right, So I'm deciding that I want to make this a toggle. So I want to push a button and have it turn on, and I want to push a button and have it turn off. But I don't want it to be a very button that I use a lot. So I have the back and the start buttons that I aren't near my thumbs or whatever. So I'm only going to push them very periodically. So I'm going to use the toggle up here, and I'm going to unbundle from my toggle array. And I'm going to copy this, and I'm going to use my back button, which is just a small little black button next to the POV on my gamepad. It's called the center pad back. I'm going to unbundle that one. And if it is true, so I could use a case structure here, or I could use a select. So let's use a case structure. All right, so if my back button toggle, remember I'm using a toggle, is true, I want to enable the agitator. And if my toggle button is false, I want to disable the agitator. Okay, so I think we have programmed everything.